M, A and B. You cut the string, and at that very moment, what is the acceleration of A and what is the acceleration of B? Find it quickly. If you're going to cut this there, your answer would be G upward, and for this it will be G downward. You got this? You're doing really well. Okay, let's discuss. If you cut this, then the block is going to come down. There's no force at all except from gravity. So the only mg is going to act downward and the acceleration is going to be G downward. The tension previously has to be mg for the balance of this mass. So that for this mass, there's tension equal to mg acting downward plus there its own weight mg acting downward, and the spring force, which should be equal to 2 mg for the balance, should have been acting upward. Now when tension is gone, this is gone. Now these are the forces acting. Spring force will continue to exist. So there's a net force of mg upward, so the block has a net acceleration of mg upward. Okay? Okay, now let's solve a problem asked in IIT JEE. They asked it in 2006. It was a 3 marks question. They said that you cut it from here and they were asking for the acceleration of m and 2m the very moment you cut it. So you can tell them, right? They gave you 4 options. It was an objective type problem, but I'm not giving you the option. You tell me straight away what is the acceleration of this and what will be the acceleration of this. Now after solving the previous 2 problem, it shouldn't be any problem for you to say that the acceleration of m will be G downward and the acceleration of 2m will be G by 2 upward. This should be straight and simple for you. Problem? No? Shall we move ahead? Okay. Okay then. Here is another easy problem for you. This is a 2 kg block. It is attached via spring to a 3 kg block. And during their course of journey, at one point, 3 kg block has a 2 meter per second square of acceleration. So the question is, at that very moment, what is the acceleration of 2 kg block? 3 kg block is having acceleration of 2 meter per second square. What's the acceleration of 2 kg block? Finding that is easy. If 3 kg block, the answer would be 3 meter per second square. And that should be straightforward for you. Now, if you draw the FBD of 3 kg block, now this is moving to its right. You remember Newton's first law? The acceleration will be in the direction of force always. So acceleration is to its right hand side. The force should be to its right hand side. And the only force in horizontal direction could be spring force. And the spring force is to its right. That means the spring should be compressed so that it would be pushing the 2 kg block and 3 kg block outward. 3 kg to its right and 2 kg to its left. So the thing is, 3 kg is having a force to its right, so the net force will be mass into acceleration, so the net force will be 6 Newton to its right. For 2 kg, you will have a force to its left. The force will be outward for both. So 2 kg will have an acceleration of 3 meter per second square to its left. Okay, not a problem? Okay. Let's quickly then also go through this problem. A block is kept stationary like this. A block of mass m is not given, is kept stationary using this kind of system. There are 2 springs and it is in its stationary position right now. Now the question is, if the upper spring is cut, I'm telling you, if the upper spring is cut, then the acceleration which the block has is 6 meter per second square. You're cutting it from here. if the upper spring is cut from the block, the acceleration is 6 meters per second square. Then they're asking you what will be the acceleration if the lower spring is cut from here. Tell me. What is your answer? What will be the acceleration of the block if the lower spring is cut? I'm telling you the answer. If the lower spring is cut, the acceleration will be 4 meters per second square. And I really hope that you got this answer, because I'm not going to discuss this because we had enough discussion. Now you should be able to do it on your own. Okay, so let's see one more. This is your system, A and B, and what you do is you cut the spring from here, and the moment you cut it, they have been asking you certain questions. Suppose this is of mass m1 and this is of mass m2, and it is given that m1 is greater than m2. Now I'm giving you 4 options and you have to choose the options which are correct. Acceleration of m2 will be upward. Both blocks will have same acceleration equal to m1 minus m2 upon m1 plus m2 into g. Option number B. Option number C is acceleration of m1 will be equal to 0. And option number D is magnitude of acceleration of both will be non-zero and unequal. These are the 4 options, and you please kindly tell me which are the correct options among the given 4 for this given situation. Okay, the answer I think is A is correct and C is correct. You got both these 2 options? If you got, you are very good. If you didn't, you're not bad. Okay, option number A, let's discuss. If you want to cut this string, what would happen? The spring force is going to vanish. Now, if it is at all in equilibrium, then the spring force at block B is downward, away from the body. And that downward force, if that vanishes, then suddenly there will be net upward force. So block B will have to go upward. So option number A seems correct. Acceleration of M2 will be upward. And acceleration of A, acceleration of B. Now see, acceleration of B. Acceleration of A. Acceleration of A is not going to be hampered, because acceleration of A, there is a spring, and spring is not going to change its position. So whatever be happening here, the spring is going to have the initial elongation as it had, and that is not going to hamper the FBD of A. Net force will not change on A. So the acceleration of A will be equal to 0. That's right. This is wrong. And it says they both have non-zero acceleration. No, A has 0 acceleration. This is wrong. A and C are the right options. Okay.